So based off of what I've been seeing, based off of what I'm seeing as far as some of your probability work, I want to spend a day today and kind of, number one, we are going to introduce kind of a new probability concept, but in addition, I do want to kind of cover some of the ones we've already covered, just because some of you are getting it and some of you, quite honestly, are not quite there yet. So let's start with this. This is actually not a 6th or a 7th or an 8th grade concept. It's actually a 5th grade concept. But it says, if I decide to make sandwiches using wheat or rye bread, turkey, ham, or salami, and Swiss or cheddar cheese, how many combinations of sandwiches can I make if I choose one type of bread, meat, and cheese on each sandwich? Now, hold on for a second. This is so that you understand when it says how many, I'm literally just looking for a number. But in order to find that number, you can use one of two ways. You can either use what's called the counting principle, which I'll show you in just a second, or you can make what's called a sample set. And I wanted to make sure that you are familiar with the term sample set. It should have been a term that you knew in 5th grade, but I want to make sure everyone understands it. And basically what it amounts to is you end up making a tree diagram of all the different combinations that you can have. For example, from a sandwich standpoint, we had rye bread or we had wheat bread, right? And then after that, you're going to pick a meat. How many different meats were available? Three. So you have turkey, ham, salami. So after the bread, each of these, turkey, ham, salami, turkey, ham, salami. And then after that, we had two different types of cheese. We had cheddar and, is it Swiss? So off of each of these, you have cheddar and Swiss, cheddar and Swiss, cheddar and Swiss. Yeah, you can, and I'll show you a couple different ways. But basically what it means is one sandwich is rye, turkey, and cheddar. One is rye, turkey, and Swiss, and so on and so on. What you end up with are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 different combinations. Bless you. I'm aware because I'm a math teacher. I just want everyone to listen. Okay? Now, the other way to have solved that is to have simply taken the number of options at each point and multiplied them all times one another. Since there were 2 bread options, 3 meat options, and 2 cheese options, 2 times 3 is 6, times 2 gets us our 12. That is called the counting principle. Well, here's the thing. What you have to know how to do, you also have to know how to make a sample set. By the way a sample set would look is you would actually write rye, turkey, cheddar. Then you would do rye, turkey, Swiss. And you would keep making a list until you've come up with all 12 combinations of different types of sandwiches. No, but I'm saying if it asks you for the sample set, that's your only choice. Okay? Any questions on that? I wanted to make sure everyone understood what a sample set was. It's just a list of all the different combinations. Any questions on that? All right. So it says, what is the probability of rolling a 3 on a die, flipping the coin and getting heads, and then rolling an even number on the die? First of all, we need to find the individual probability of each. What's the probability of getting a 3?
1/6.
1/6. Flipping the coin and getting heads?
1/2.
Even. 3/6, which simplifies to 1/2. Everything is always connected via multiplication. There's no cross simplification opportunity, so you basically have 1/24. So that you know, because we talked about it briefly, is this an independent or a dependent example of probability?
Independent.
Why is it independent?
Because they don't need the other one.
Because you don't need the other one to create a probability. You need to understand, Cameron, dependent probability is where you take something out of a bag and you don't put it back, which then changes the outcomes after that. You need to understand the difference between independent probability, which means independent probability is just we found the probability of these independent of the other. This is always going to be 1/2 no matter what happens here or here, right? The probability of flipping a coin and getting heads is independent of the others. The dependent probability comes into play whenever you're changing the probability environment. When you take something out of a bag or whatever and you do not put it back, that's called dependent probability because it changes the probability environment for everything after that. Jonah?
On a problem that you gave us, there was like red marbles and blue marbles and
Yep. Uh-huh.
And you said that what's the probability of taking one out? It's random that it's not like green.
Uh-huh.
And then you say, what is the probability of red? What's the one that you chose is not a green?
Yeah, I didn't actually like that one. When they do dependent, what they will typically do is say, without replacement, they love those terms, without replacement, what is the probability of red and then red? So the first probability of red is simply 1, 2, 3, 4, 5 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 5 13ths. And then on the next one, it would be 4 out of 12. It would be 4 out of 12. And then we look for cross simplification opportunities or regular simplifying, like Brent, this is 1/3. So you end up with 5 39ths.
Yeah, and that's not very good.
And this is dependent probability. This is dependent probability. Okay, no, I'm saying the one that you were referencing, I didn't like that question. You'll never see it like that, so it doesn't matter. Okay? It's not really, you can't really calculate that because you don't know if you got it or if you didn't.
Yeah, you have to act.
Okay? By the way, what are the odds of this happening?
5/34.
5/34ths.
Yeah.
5/34ths. Okay? Maya? Oh, okay. Yes?
For the compound probability worksheet, sometimes it doesn't say for the things like if you're going to replace it or not replace it. Was it okay if we just assumed it was not replaced?
You assume it's replaced unless it tells you it's not. But typically it tells you. Typically it tells you. Okay? We're gonna go back through a worksheet today that's just kind of a reminder of that. So here's what we're gonna do as we get ready for lunch. When we get back from lunch, we're gonna talk about experimental versus theoretical probabilities. It's another one that you have to understand the differences between experimental versus theoretical. Then you have two worksheets, one on experimental theoretical, one on probabilities. The probability one is going to be homework, but you're welcome to take it home if you wish. You don't have to complete it. It's only one page. It's like yesterday. It's like the first one is a little bit longer than the second one. The second one goes very, very quickly. Okay? And that's basically it. Tomorrow we're going to do a little bit of mixed practice. And then remember, Friday I'm out. But Friday I'm going to give you the Unit 8 review. And you're going to work through that in groups. Make sure that you're ready for the test next week. Okay? All right.